This is your pre-lab video for the analysis of silver group cations. The purpose of this lab is to determine the presence or absence of three different types of cations that are in a mixture. First, we're going to have to separate these cations. So part of this procedure will be to separate the different cations, and then once you've successfully separated them, you'll perform a confirmatory test on each and determine whether or not they're present. So this is a qualitative lab. We're not working with numbers, we're not working with measurements, but you do have to be very diligent at recording your observations because that's your data. You will have a formal written lab report. Safety and housekeeping. We're working with 6 molar HCl, so make sure you remember your acid safety precautions and rinse thoroughly if you come in contact with the acid. We actually are also working with 6 molar ammonia, so same thing. It is a base, but be careful with it and try not to get it on you. If you do spill it, notify your instructor and rinse it from your skin immediately. We're going to be working with centrifuges, and you need to make sure that they are balanced. If they're making a loud noise, stop them, take your test tubes out, make sure that you have an equal amount of solution in the test tubes and that you always have test tubes of equal volume opposite each other. All waste that we produce during this lab needs to be collected. So any of your solids or your liquids, they'll all be collected in the hood at the front of the room. And if you do have some solid down in the bottom of your test tubes, we do have cotton swabs that you can use to help clean that out. They can be just thrown away in the trash. As always, wash your hands and wash and wipe dry your lab bench before leaving. Keep the hoods and the common areas neat. Wipe up spills immediately. Notify your instructor if it's a large spill, please. These are the 3 ions we'll be working with: silver, lead 2, and mercury 1. So like I said, we need to separate these ions and test them each separately. You will be given a known mixture that will have all 3 ions present. Then you will observe what that positive test looks like for each. Since we have the known mixture and we have all 3, we can observe what each of those positive tests look like, so that when we test our unknown mixture, we can compare that with the data that we generated from our known mixture, and we can confirm whether or not they're there. So our conclusion of our report must indicate whether or not you have or do not have each of the ions. So list them separately. Say silver was present, lead was absent, mercury was present. Pause this video right now and record this data table in your notebook. If you have this in your notebook, then your lab instructor will know that you watched the video and recorded this data table as requested. The gray portion here just means we're not going to be putting anything in that spot. These numbers are the procedure numbers from your lab manual. So you will record your observations here. Half of this data table is for your known mixture. The other half is for your unknown. Make sure you write your unknown number here. Writing it this way allows you to compare your known to your unknown, seeing any similarities or differences. So your confirmatory tests are here in the second column and fourth column so that you can compare the test for lead, for example. This is what it looked like when I knew that I had it present. Is this the same? Yes, I'm positive for lead. We're going to be separating these ions based on differences in solubility. So if we have a difference in solubility and we can create a solid and separate that solid from something that is dissolved in liquid, then we can separate our solution from our solid here using centrifuge. So the first step of our lab here is to take our mixture of metal cations, add hydrochloric acid, and make a solid of all 3 of them. Okay, so this will precipitate all 3 of these, and they will be down here in our precipitate or our pellet after we have run our centrifuge. The reason for that is to get rid of any of our additional anions. Okay, so once we have made our precipitates with our chloride for each, then we just have a chloride anion, and anything else that's still dissolved in the solution we can discard. So we will have our solids, and then we will separate out any other metal cations that are dissolved, as well as any of our anions that are different from the chloride. This is the procedure that's right out of your lab manual. So for step 1, you'll be adding hydrochloric acid and making your precipitates of all three. Okay, so that's here. This is the only step that you can discard what's on top, the top portion. Okay, so the centrifuge and decant. Decant means to pour off the liquid on the top, reserving the solid. So you want to keep that solid over here for step 2A and continue on. But whatever you pour off here can be discarded. Now remember, we're capturing all of our waste, so just have a waste beaker and you can pour it into there. Once we have all three of these in solid form, we are going to separate out these ions by selectively dissolving one at a time. The first one we will dissolve is lead. Lead will dissolve. Lead chloride is more soluble than silver chloride or mercury chloride in hot water. So we're going to add hot water, hot purified water, and dissolve your lead chloride. So you can centrifuge this immediately so that you don't allow this to cool and let your lead chloride precipitate back out. Then you will pour off again, you will decant the top portion and save it this time. So you're going to pour that into like another test tube, a separate test tube that you've labeled 5B. This is now a solution containing your lead ions. If you add chromate to your lead ions, you're going to make a precipitate, which is very bright yellow. That's your confirmatory test that lead is present. You'll then be done with that test tube. Set it aside so that you can compare your unknown to it. The solid that was left at the bottom contains silver chloride and mercury chloride. You want to wash these to make sure that you've removed all of the lead chloride or all of the lead ions from it. So just continue to add some hot water, mix it up with your glass stirring rod, centrifuge, decant off the liquid, and then that you can just throw away because you're just washing all of the lead off. Once you have a nice clean sample of silver chloride and mercury chloride, you're going to add concentrated ammonia to it. And two things are going to happen. Again, remember, we wanted to selectively dissolve one or the other. And what ammonia does is it selectively dissolves the silver. With this reaction here, it creates a complex with the silver ions, and this complex happens to be soluble. So we have a soluble silver now. And you pour that off into another test tube, okay, labeled 7B. And that solution again contains your silver. The test that you'll be doing is you'll add some acid to this complex. And here's your reaction, what happens down here. So your silver complex plus acid brings that back to silver chloride. And you can see that precipitate out as a white precipitate. Positive test for silver. Back over here, you've poured off your silver. And what's happened with the mercury is down here. So we had the mercury chloride. We added the ammonia to it. And then we made a solid, okay, the solid mercury substance as well as mercury liquid. So this is the pure mercury element as well as this other precipitate. So if you see a gray precipitate here, then that confirms the presence of mercury. So if we go back up to the data table, all of the steps that I just described, you will be performing with your known mixture, and you will have the observations for what a positive test for each of these three ions are. Then you'll go and do the exact same thing with your unknown solution that you'll get from your instructor. And then you'll be able to compare whether or not you have these ions in your unknown solution. So make sure that you conclude which ions are present in your unknown. Make sure you write down your unknown number so your instructor will know what you have and can give you a grade based on your accuracy of this qualitative lab. So have fun with this one. It's pretty fun. I think you'll enjoy it. And that concludes this video.